All right, hello virtual chemistry students. Again, I'm trying something new. This is a demo that I'll be doing in class at the beginning of class on Thursday, so please watch this before you do anything else. For class today, what I want you guys to be thinking about as we start this class is what it means for something to react. So there's a story that's popular amongst many chemistry teachers. It tells the story of Ira Remsen, who wrote a short story about his interpretation of the phrase nitric acid acts on copper. What does that mean? Because we all know what copper is. I have a piece of it right here. And you might know what nitric acid is. It's an acid, and its formula comes from nitrate, so you might be able to figure out how it got that name since we've talked about that. But that term acts on, nitric acid acts on copper, is what we're going to look at today. What does it mean for a chemical reaction to take place? And also, what are we looking for when we're looking for a chemical reaction to take place? How do we know that this is going to be a chemical reaction, whereas boiling water is not a reaction, it's just a phase change? So we will go ahead and get started, and then we'll talk about some of the things that we'll look for. This right here is our nitric acid. I have about 25 milliliters of it. And this is called a round bottom flask. It has this nice glass neck that comes over into a beaker full of water. I know you can't see all the way down, but that's all right. The hose goes all the way to the bottom. So we're going to add our nitric acid. There we go. And now the copper. So I put a rubber stopper. This flask is totally contained. What we see happening is immediately the nitric acid starts to dissolve the copper, and what it forms is nitrogen monoxide that almost immediately turns into this brown gas you're seeing that is nitrogen dioxide, so 2 oxygens, and it's traveling over here and then going through the hose. It's almost out of your camera view, but you might notice at the very bottom of the flask right here, it's a little bit greenish. So that is the copper nitrate that's forming. Nitric acid is reacting with the copper and it forms copper nitrate. So that is one of the types of reactions we're going to look at today. What I'd like you guys to do right now while this keeps bubbling for a little while is I'd like you in your notes to draw this apparatus, everything that you see here. You can imagine what the bottom of the flask looks like, but don't just cut it off at the neck. Just draw the rest of what the flask would be. I want you to label everything clearly. You don't need to use technical terms. I want you to use terms you know. But I want you to make as many observations as possible. You can see the nitrogen dioxide has gone all the way down in through the tube. It's slowly working its way all the way through. And at the end, we're going to see what has happened to the copper. So when we look for signs that there's a chemical reaction, there are a few things that we look for. They're not always going to be present in every reaction. One of them is a temperature change. The container might get small, the temperature might go down or go up. In this case, if you feel the outside of the flask, it's very warm. So that's one indicator that there could be a chemical reaction happening. Obviously, that also happens when you have a phase change, which is why people get phase changes confused with a chemical change. They're not. Phase change is just moving from whatever phase, and there's not any real chemical difference. Another thing that you can look for is a color change, which we have obviously had. We have this green solution that is at the very, very bottom, and then we also have this brown NO2 gas. Something else you can look for is the formation of a gas, so bubbling. In most cases, again, don't get this confused with boiling, because that does happen to have bubbles forming, but they're not a brand new substance. It's just water, but as a gas. We didn't see this here, but that doesn't mean that this isn't a chemical change. It just means it didn't happen to have that sign that there's a chemical reaction. Finally, another form of another sign that there's a chemical change happening is that you form something called a precipitate. So that's typically what we see if we take two aqueous substances, which we'll look at today, mix them together, and they form a solid. So that's another way that you can see there's a chemical change happening. Again, we did not see that here, but that doesn't mean this isn't a chemical reaction. So I want to describe to you something that I can see, and I'm not sure you guys can. We are noticing that before, this brown gas was bubbling all the way through the hose. And it did that for a while. Particularly as this warms up, it is going to be pushing the gas this direction. But now that this flask is starting to cool just a little bit, we see that the NO2 is actually being pushed back up the tube by the water. The hose is, water is being pushed into the hose, and it's pushing the gas back into this flask. So we're going to see what happens when it pushes it all the way back into this flask. It might take a minute. What I would like you guys to do is start a second drawing. You can just go ahead and start getting your basic outline of the round bottom flask and the Erlenmeyer flask, because when this happens, I want you to do a second drawing and make a second set of observations of what happens as it's slowly being pushed this direction. There is a question that I would like you to email me sometime during class today, or actually sometime before tomorrow. Let's say that. If the water is pushing the NO2 back into its original flask, what do you think is pushing on the water? What is making the water push the NO2 back into the flask? What you may have noticed in this tube in particular, and now in this glass tube, is that it is the water itself that is climbing up. It's not that there's air pushing this NO2, it is the water that is pushing it. So what is pushing on the water to make it go back into the round bottom flask? Just write that on a piece of paper. You can email me a picture. If you want to send me an email of your apparatus, you can do that too. This is where you should start drawing your second drawing as you see the water begin to trickle down in. What is going to happen? You can see the water level dropping dramatically here. And we had that very small greenish line. That was the copper nitrate that formed. And so the water is diluting it, giving us this blue colored liquid. Remember when we did the flame tests, copper gave us a flame that was kind of this color, a little bit like greenish blue. And if you were trying to do something with a firework that was going to be green or blue, you would use copper or some copper compound, like copper nitrate. All right, I am going to close the filter. As you can see, there's still a little bit of NO2 in this flask. It's not something that smells great, not something that I want to be breathing in. And then we'll come back and clean up.